Hello everyone, this is Nilima and in this video I am going to discuss the electronic configuration. How to write the electronic configuration of an atom. What is electronic configuration? Electronic configuration is the distribution of electrons in atomic orbital. Okay, so this is the Bohr's model of atom. In the center there is nucleus which hold protons and neutrons, and outside the nucleus there are shells in which electrons are present, and the maximum number of electron that a shell can hold is according to the formula 2n to the power 2, where n is equal to 1, 2, 3 and so on, which is the for the first shell n is equal to 1, for the second n is equal to 2, for third n is equal to 3, for fourth n is equal to 4, and this n is called the quantum number. So for the first shell, the maximum number of electron which can present in a first shell is equal to 2, 1 square, which is equal to 2. Okay. For second, it is equal to 8. For third, it is equal to 18, and so on. You can find the maximum number of electron which a shell can hold. Now, how to write the electronic configuration of an atom? Before writing, let us understand what is energy level, what is subshell, and what is orbital. This shell around the nucleus are the energy level where you can find the electrons, and so these are the shell 1, 2, 3, 4, and inside each shell there is some subshell. Like for the first shell there is one subshell S. For the second shell there is two subshell S and P. For third there are three subshells S, P and D, and for fourth there are four subshells S, P, D and F. Now this subshells has orbital, okay, where the probability of finding the electron is maximum. S has one orbital where you can find the electron. P has 3 orbital. D has 5 orbital. And F has 7 orbital. Okay. And each orbital can hold maximum of 2 electrons. So S can hold maximum of 2 electrons. P can hold a maximum of 6 electrons. D can hold a maximum of 10 electrons, and F can hold a maximum of 14 electrons. Now let us see how the electrons are arranged in this orbital. Okay, the farther you move from the nucleus, okay, so the large number of electron a shell can accommodate, and larger it is. For example, the first shell can hold only 2 electrons, while the third shell can hold 18 electrons. So it is away from the nucleus than the first shell, so it is larger and it can accommodate more electrons. Now how to write a electronic configuration? So first follow some rules. Electron first occupy the lowest electronic energy level, electrical orbital, which is available. Okay. So 1s, next is 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f. So first the electron will occupy 1s, then the 2s, 2p, 3s, then 3p, 4s. And each orbital can hold a maximum of 2 electrons only. And they must be in opposite direction, means they spin in opposite direction. The electrons in an orbital, there is 2 electrons in an orbital and they spin in opposite direction. Okay, so the one is going like this way, the other will go this way. Okay, if there are two or more than two electron orbitals, like in P there are 3 orbitals and they are at the same energy. So first we half fill these orbitals. If there are, like, suppose there are 2 electrons. So instead of putting the electrons like this way, we first half fill the all the 3 orbitals, 1 1 like this, and then we come to the first orbital to fill it if the electrons are remaining. Let's understand this with an example. So let's take the example of sodium, how to write its electronic configuration. First let's draw the diagram so that we can understand which energy in which orbit to put the electrons. Okay, so the sodium atom has 11 electrons in it. Let's start writing the configuration. First start with 1s, maximum 2 electrons it can hold. So 1s2, 2s, it can also hold a maximum of 2 electrons. 2p, it can hold a maximum of 6 electrons. Still 2 electrons are remaining, 6, 7, 8, 9, 10. After 2p comes the 3s. So 3s and 2, 6, 7, 8, 9, 10, 3s, and only 1 electron is remain. So we put here 1. How we can represent it by diagram? 1s2, so 1 and 1. Okay, 2s2, 2 electrons, both spin in opposite direction, so we represent it by like this way, in opposite direction. Okay, 2p6, 3 orbit, first 3 electrons, 2, 3, then we write 4, 5 and 6. 3s1, only 1 electron. In my previous video I explained you what is a valence electron. The electron in the outermost occupied energy level of an atom are called valence electrons. So sodium has 1 valence electron. This is the valence electron. Now let's take another example. How to write the electronic configuration. Let's write the electronic configuration for calcium. Calcium has number of electron which is equal to 20. So electron first accommodate the lower energy level. So 1s2. Now come the second shell, 2s2, 2p6, 10 are filled, 3s2, 3p6, 18. Okay, 18. Now only 2 are remaining. After 3p there comes 4s. Instead of 3d, the next energy level is 4s. Now why 4s come first and the 3d? I will discuss in the coming video, but for now you just remember this diagram, how the electrons are filled in the energy level. Okay, so 4s will come and we put the remaining electrons in this orbital. This is the diagram. 1s2, 2s2, 2p6. First we half filled it, then the remaining electrons come. 3s2, 3p6, 3, 4, 5, 6, 4s2. Now let's write some more electronic configuration. Let's take the example of gallium. Okay, it has 31 atomic number, which is the number of electron. This is the diagram that we follow to write the electronic configuration. Okay, let's start writing. So first energy level is 1s2, 2s2, 2p6, then come 3s, then 3p6. How many are there? 6, 10, 18. Now after 3p it comes the 4s2, 20. Now 3d, and in d you can accommodate 10 electrons. Now there are 30, only one is remaining, which we put in 4p1. Okay, this is how we write the electronic configuration. That's all for today. In coming videos I will discuss, or I am going to tell you what are ions, how to write the electronic configuration for ions, why the 4s electrons first accommodate in 4s, then 3d and not in 3d. So keep watching my channel and subscribe it, like it. Thank you.